The atomic number is a number in chemistry that is really important because it is the number of protons, but the reason that that's important is because it identifies the element. So notice that I put it in yellow, capital letters, and exclamation points, and that indicates that it's extremely important. And what I mean by the fact that it identifies the element is that the number of protons tells you what element it is. So what makes carbon a carbon atom? All it has to have is 6 protons. If you take away a proton from carbon, it becomes a completely different element. It becomes boron. So if you look at this symbol, you'll see from the periodic table, the top number tells you the atomic number, and that tells you the number of protons. And again, the reason that's important is because it identifies the type of element that you have. You can always find the atomic numbers by looking at the periodic table. So I won't necessarily give you the atomic numbers because if I tell you what element it is, you can just look up the atomic number and find out what it is on the periodic table. In a neutral atom, we already talked about protons having a positive charge and electrons having a negative charge. So if the entire atom is balanced out, meaning that it's neutral, what it's telling you is that you have the same number of protons as electrons. So if you know the atomic number of an element and you know that it's neutral, then you can say that the electrons are going to match the protons. So the reason it makes sense that the protons and electrons are equal is because the neutral charge has to cancel out the positives and negatives. So the positive charges from the protons have to balance the negative charges from the electrons. The next vocabulary word is the word ion, and this is probably a new word to you, so you want to make sure that you star this one and make sure you understand what it means. An ion is formed when an atom gains or loses an electron and becomes charged. Formed when an atom gains or loses an electron and becomes charged. So the 3 words that I want you to be able to match up in your head are ion, electron, and charged. I want you to circle those 3 words in your notes. Ion, electron, and charged. When you see the word ion, you need to associate with the particle electron, and you need to understand that it means that it's going to become either positive or negative. But keep in mind that it's the opposite of what you think. So if you gain an electron, it actually becomes negative because electrons are negatively charged. If an atom loses an electron, it becomes positive because it's losing the negative charge. So it's kind of the opposite of what you think. So if you take a look at these 2 examples, you see that sodium +1, what that's +1 is telling you is that it lost 1 electron. And the sulfur -2 tells you that it gained 2 electrons. So to find the number of electrons in an atom, start with the number of protons and then do the opposite of what the charge says. For example, let's start with calcium. If calcium was neutral, meaning that if it did not have a +2 charge on it, the number of protons would have to equal the number of electrons. So if you look at your periodic table, and if you look over to the left of it, and if you don't have a periodic table out, just go ahead and pause this video and take one out so you can have it in front of you. So calcium has an atomic number of 20, which means that it has 20 protons. So if it was neutral, it would also have 20 electrons. However, the charge +2 tells you that it lost 2 electrons, so you're going to take away 2 from the 20, and you should get 18. And check that it makes sense. If you have 20 positive charges and 18 negative charges, it makes sense that it would have a +2 charge overall. The next one is fluorine, and fluorine is way over to the right on the periodic table. So fluorine, if you look at the atomic number, has an atomic number of 9, which means that it has 9 protons. If there was no charge on that F, then it would also have 9 electrons. The -1 tells you that it gained 1 electron, so now you have 10. And just check and make sure it makes sense. If you have 10 electrons and 9 protons, it makes sense that you would have 1 extra negative charge, which is why the whole atom is a -1. Try the next 2 by yourself, and I'll tell you the answer. Sodium is all the way over to the left if you're looking for it. And you should have gotten 10 for that one. So you start with the 11 that's on the periodic table, do the opposite of what the charge says, so take away 1, and you should end up with 10 electrons. Phosphorus is over towards the right. It's a few columns over from the right. And phosphorus has an atomic number of 15. So you do the opposite of the charge and add 3, and you should get 18 electrons. The next important concept is mass number. And the mass number is the number of protons and neutrons. So you're just going to add the protons and add up the neutrons. Remember, we do not include electrons. We talked about this earlier because electrons really don't weigh anything. So the mass is all concentrated in the nucleus. It's only protons plus neutrons. So if you look at this isotope symbol, and you'll see this a lot, you're going to get two numbers. If you can remember that mass number includes two particles, atomic number is just one particle, you can figure out that the bigger number will always be the mass. So 9 in this case is the mass number, it's the protons plus the neutrons. 4 is the atomic number, it's just protons. So looking at this, you should be able to see that you can easily solve for the neutrons by just subtracting them. So 9 minus 4 means that this atom has 5 neutrons. So to find the number of neutrons in an atom, you just take the mass number and subtract the atomic number. Go ahead and pause this video now and see if you can figure out the protons and neutrons for the first 4. Don't worry about number 5 yet, I'll talk to you about that in a minute. Try the first 4. For number 1, you should have gotten 11 protons and 12 neutrons. For number 2, you should have gotten 16 protons and 16 neutrons. Number 3, you should have gotten 47 protons and 61 neutrons. And number 4, you should have gotten 82 protons and 125 neutrons. Now the last 3, notice that they look a little different. For the last 3, there's a dash and then a number. The dash is not a negative sign, it's just a dash. And if I only give you one number, the number that I'm giving you is the mass number. I don't have to give you the atomic number because, like I said before, you can always look that up. To be carbon, it has to have an atomic number of 6, and that's on the periodic table. To be carbon, it doesn't have to have a mass of 12 or 14, so it could change the mass, and so that's why I'm giving you the mass number. So for number 5, the mass is 14. So if you look at the periodic table, it has an atomic number of 6, which means it has 6 protons, and then 8 neutrons, 14 minus 6. Fluorine is in the top right corner of the periodic table. So if it has a mass of 19, minus the protons on the periodic table, which is 9, you should get 10 neutrons. So 9 protons and 10 neutrons. And for the last one, chromium has a mass of 52. And if you look at the periodic table, it has an atomic number of 24. Chromium's kind of in the center of the periodic table. 52 minus 24 gives you 28 neutrons. Keep in mind that sometimes I'm not necessarily going to give you a mass number. So if I don't give you a mass number to work with, you can take the mass that's on the periodic table and round it to the nearest whole number. In just a minute, we'll talk about why it's not a whole number on the periodic table. For now, just keep in mind that you can round it to the nearest whole number if I don't give you one. If I give you a mass number, always use the one that I give you. Chemistry joke of the day: lost an electron, so he's positive. Alright, the next word is isotopes, and the problem with the word isotopes is that it starts with an I, just like the word ion, so make sure you remember the difference between them. For ion, remember we stressed electron and charge. Isotopes, I want you to stress neutrons. So these are atoms that have the same number of protons, but their neutrons are different. And since they have different numbers of neutrons, their mass is going to be different. Because remember, the mass includes neutrons. It doesn't include electrons, but it does include neutrons. So for isotopes, the two words I want you to think of are neutrons and mass. Neutrons and mass. Go ahead and circle those two words on your notes. So for example, if you look at these two carbon atoms, this is carbon-12 and carbon-14. They both have 6 protons because that's what makes them carbon. They have to have 6 protons, but notice that one has 6 neutrons and the other has 8 neutrons. And so since their neutrons are different, they're going to have different masses, and we call these isotopes. Go ahead and pause this video and see if you can figure out the protons, neutrons, and electrons for each of these. And you should have gotten for neon 20. If you look at the periodic table, neon has an atomic number of 10, which means it has 10 protons. Since there is no charge, the protons are going to equal electrons, so that's also 10. And if you subtract it from 20, you get 10 neutrons. So 10 for the first three. For the next one, it's still neon, so you still have 10 protons. It's still neutral, so you still have 10 electrons. But in this case, you have 11 neutrons, 21 minus 10. Same thing for the last one, 10 protons and 10 electrons. The only difference here is that you have 12 neutrons. So notice that for isotopes, the only difference is the number of neutrons. The next thing we're going to talk about is average atomic mass. So the problem with putting a mass number on the periodic table is that not all elements have the same mass. So what they do is they take an average of all the elements in the world, all the isotopes of a particular element, all the isotopes of a particular element, and that's what they put on the periodic table. So the reason that it's an average is that the reason it's a decimal is that it's an average of all the isotopes. So if you take an average, you're not going to get a whole number. So these are listed on the periodic table. The units are grams per mole, but don't worry too much about that just yet. So the difference between average atomic mass and mass number. Average atomic mass is the average of all the isotopes in the world. It's going to be a long decimal, and it's found on the periodic table. Mass number is talking about the mass of just one particular atom. So it's not an average, it's just one atom. And it's a whole number because it's just the protons plus the neutrons. Either I will give you a mass number, or you can round the average to the nearest whole number. So just to stress, on the periodic table, the average mass of lithium is 6.941 grams per mole. If I tell you I have a lithium atom with a mass of 8, is that possible? Well, yes. It doesn't have to have the same mass as the average. It does have to have the same atomic number, but the average might be different from the actual mass, and that's okay. And the last thing for today is how to calculate the average atomic mass. So if you're given percentages and isotopes, all you have to do is turn the percentages into decimals, which you probably have done in math, but just to refresh your memory, you're going to move the decimal 2 places to the left because you're dividing by 100. So for example, in this one on the screen, if you have 98.892, just move the decimal 2 places to the left and it becomes 0.98892. Same thing with the bottom one, move the decimal 2 places to the left and you get 0.01108. You're going to multiply those percentages by each mass. So multiply the 0.98 number by 12 and the 0.01 number by 13, and then just add them all up together. Notice that your average should be closest to the thing that you have the highest percentage of. So since almost 99% of it is carbon-12, the average atomic mass should be close to 12, which it is. It's 12.011. Let's look at one more example. For this one, we have 90.51% neon 20. So you're going to divide it by 100 and it becomes 0.9051 times 20. Divide each of the other percentages by 100, multiply them by the numbers, and then add them all up together. And check to see that it makes sense. Almost 91% of it is neon 20, so your answer should be closest to 20, not to 21 or 22. And it is, so that makes sense. If you need some practice with all this, there's some worksheets in your worksheet packet. Worksheet 1 allows you to practice protons, neutrons, and electrons. And so does worksheet number 2. And worksheet 2 also stresses isotopes and ions and different words that we've used. Worksheet 3 allows you to calculate this average atomic mass. So if you haven't done worksheets 1, 2, and 3, go ahead and do those now, and then check with me in class to see that you get the right answers. And that's it for today.